Okay, ladies and gentlemen, hello and welcome back once again to the briefing room. Yes, indeed, my name is Eric Cavanaugh. I will be your moderator for today's show. And folks, this is such a big deal. I'm so excited about the topic today. I think you all know that I tend to be somewhat excitable in general, so it's not rare that I'm excited, but this is, in fact, particularly amazing stuff that we're going to talk about today. We're really talking about a revolution in the industry of data warehousing. This is not a small deal. So here is a slide about yours truly, and enough about me. Let's move right in. The mission, of course, as many of you know already at the briefing room, is to reveal the essential characteristics of enterprise software. It's not an easy job as a consumer of these technologies to delineate where one tool begins, another tool ends, what kind of functionality do I get, what kind of service levels do I get. There are all these different questions that can be hard to get answers to through no one's fault. Quite frankly, it's very difficult sometimes to explain what these technologies do, so we designed this whole show to create sort of a crucible that will distill for your benefit the essential characteristics of these technologies. And so what we do is we take innovative vendors, we bring them into the briefing room, and we do a live analyst briefing with independent analysts. Today, of course, we have Dr. Claudia Imhoff online. Very pleased to have her in the briefing room. So the idea is that we want to reveal a real conversation, a dynamic discussion between people who know what they're talking about, to pull out some of the more interesting kernels of information and wisdom, and there is a lot to talk about today. So the topic is intelligence. That's like business intelligence, also operational intelligence, other kinds. We do a different topic every month so that you as the end user can get an apples-to-apples comparison of what something is and how you can use it. So let's talk about BI. We're talking about Amazon RedShift today, okay? So the topic is seeing RedShift, how Amazon changed data warehousing forever. And I think anyone who's been in this industry knows that data warehousing is very expensive stuff, typically. I mean, it's really expensive. It's in the millions of dollars expensive. And just half a decade ago or more, if you wanted to go into data warehousing, it would not only cost you millions of dollars, it would take 6 months to a year to 2 years sometimes to get everything up and running. And then once you got it up and running, maybe it doesn't do everything that you wanted. You find out it's actually difficult to manage, difficult to deal with user requests. It's a pretty complex environment is the whole data warehousing world, and that's why it's expensive. In enterprise software in general, as many of you know, a lot of times you can't go to the website and get the price. So what do? You have to negotiate the price. And a lot of times what happens is you say, well, this looks great. How much does it cost? And they say, well, how much you got? Well, that's not obviously the optimal solution for the end user, for the consumer of these technologies. And what's happening is now with Amazon RedShift, goodness gracious, a data warehouse in the cloud, and if you look at the numbers, it's basically $1,000 per terabyte per year if you buy the package deal, which is significantly less expensive than any number of other options on the table today. All kinds of reasons for that happening. We've heard all about Hadoop, all about MapReduce, and a lot of these open source projects, new open source databases that can be used to fulfill very significant point solutions in your organization. Really, the Pandora's box has been opened in terms of how you can now get things done. There are so many options, so many things available to you. We're going to try to help you understand what this one particular one is all about, and it's a big, big deal. It's a big deal because of price, because of provisioning, because you can offload so many of the headaches that were very difficult to deal with. You had to hire very well-trained staff, have people on call 24/7 sometimes to deal with some of the problems you get. There are lots and lots and lots of reasons why the cloud makes sense. Now, we are going to have this weird sort of hybrid cloud on-premise environment for some time now, and that remains to be seen how we deal with all that. But at the risk of going on too long, there is a slide about Dr. Claudia Imhoff. We're very pleased to have her on the call today. And with that, I'm going to introduce Brad Peters of Birst. Let's move right along here. So Birst is a software as a service-based multi-tenant BI platform. These guys have been doing BI in the cloud for years. And Brad himself has quite a long history in the industry. There's a slide about Brad Peters. He's the CEO and co-founder. He spent the last 10 years building analytics products and solutions. Prior to that, you can see he had some other experience like Siebel Systems, for example, Siebel Analytics, which now forms the basis of Oracle's OBIEE product family. So he's been around. With that, I'm going to hand the keys over to Brad Peters. And Brad, the floor is yours.
Thank you, Eric. Appreciate that. So we're really excited today to discuss what we think is a pretty groundbreaking shift in the world of data warehousing and analytics, a world that has been restricted to the rarefied altitudes of only the most well-endowed wallets historically, and the cloud is really about taking and breaking some of those old economic models and making technology much more accessible to a much wider audience. And that was really the mission of Birst when we founded it, was how do we take the world of BI and analytics and make it significantly more accessible to organizations that previously had all sorts of cost and implementation and skill barriers to doing that. And Amazon is taking a bold move forward in terms of bringing that commodity and consumerization of technology and making it broadly available. Obviously, cost is a big issue when it comes to dealing with things like analytics. And historically, organizations, when they looked at consolidating a lot of their information for the purposes of analyzing it and making sound fact-based decision-making, building things like data warehouses and building things like data marts, they restricted it to data that was of such information intensity and economic density that it made sense to spend the millions of dollars on those systems to be able to support it. And what that meant was that a large percentage of the analytical needs of organizations went unmet. There's a lot of distributed spreadsheet hacking and things that are going on in organizations today because people are trying to make do, not having access to a single consolidated place where they can have the right information in the source data. And now with the economics of cloud, we're seeing that pendulum shift back to empowering users to be able to take the raw data and be able to do interesting things with it. $1,000 per terabyte is a fundamental shift. And I think whatever reticence organizations have had historically about the cloud, it's new and it's different, and technology organizations are historically conservative, and new and different in and of itself can be scary. But it's going to be difficult over the next 12 to 36 months to be able to argue to the CFO why you should be spending 5, 10, 20x for that system with, from name your legacy vendor out there that ultimately doesn't provide you, really much more than a database. And if you've got to maintain it and staff it and do all that stuff, that's a big deal. Amazon is providing something that really brings those cost barriers down. And this whole world of Hadoop, which is all about originally Facebook and Google and guys like that saying it's just too expensive to store all this data in a traditional relational database and analytical database, so let's create this Hadoop thing to bring the cost down. Well, Amazon is actually bringing the cost of those relational databases down darn near to where the Hadoop costs are. In fact, commodity MapReduce is only a little bit less, at Amazon than the RedShift offering. So it really, the trade-offs that people had to make, do they want low cost or do they want queryability, the ability to join data from different places and bring it together? Some of those trade-offs go away in the world of RedShift, and that's very, very transformational in the marketplace. And it's something that we're very excited about. Amazon Redshift and Birst are very well aligned in our goals as organizations. Amazon has set out trying to bring IT infrastructure and technology infrastructure and make it faster and more agile and simpler and more economically effective for organizations. Birst has been doing the same thing with analytics and business analytics. And Amazon's focusing on the infrastructure for where data is stored and where it's managed. Birst is focused on the infrastructure for how people interact with data and manage that data. So whether it's automating the data administrative tasks or automating the transformation and analysis tasks, they're both important in terms of how folks get value out of this data. One of the biggest challenges that we've seen historically in BI analytics is if you build it, will they come? I build a data warehouse with the knowledge that if I stick a bunch of stuff in there, all of a sudden business users are going to be able to go get value out of it. And one of the biggest failure points for BI and analytics historically is that that ability to get value out of that data has been challenging. And so what we have here today is an end-to-end solution that not only allows you to store data, but also allows you to manage it, manipulate it, and allow business users to extract value from that data, which is really the core. If you don't get any value out of it, it's not worth investing in it. So that's really part of the great opportunity here. And we're excited about it because Birst fundamentally was built on the notion that analytics, data sets should be browsable, they should be queryable, they should be explorable in their fullest richness. And that's really what relational databases and analytical databases were designed to do. The MapReduce Hadoop data scientist role that's out there today is exciting, but it's generally been constrained to a relatively small part of the organization because most people don't speak Java, most people don't speak MapReduce, most people don't speak Hadoop infrastructures and things like that. So it's very difficult to get value out of these infrastructures, which was worth it for folks if you had a really highly skilled individual that you could find, and the economics of data were so compelling it made sense to do that. But it did leave out in the dark and out in the cold the vast majority of business users and organizations that want to be able to interact with this data as well. And really that's been the domain of relational databases, and that's one of the exciting things about RedShift is it really brings to large data sets that queryability and that browsability for the business users that are there. The thing that's important to understand is that once data is in a database or a data warehouse, you got to do a couple of things to it in order to make it accessible for business users, because obviously if they can't access it, it loses a lot of its richness and value. And these two things are pretty important when it comes to making data accessible. If you just put it in its raw form, business users then have to figure out how to hook it up and how to navigate it, and that's generally not something that they're used to doing or necessarily qualified to do. So really what you need to be able to do is organize the data in the database such that business users can ask interesting questions of it, be able to ask as is, as was questions, ask single version of truth questions, ask questions across hierarchies, across data sources. Those types of sophisticated business questions that business users have, they're likely not going to be able to understand how to bring the data together in those sophisticated ways very quickly, and they're not going to necessarily have the tools to do so. So in addition to building the data infrastructure itself, you need to be able to organize the data so that you can ask those questions, and then you need to be able to put the tooling in front of the business users so that they can ask those questions without having to be data scientists. And I think once we can do that, once we can enable vast amounts of data to be collected from across the organization, consolidated, organized, and then leveraged by large numbers of business users, we really can change the game here in terms of BI and analytics. And what it really comes down to is bringing together multiple different disciplines that have historically been separate in the world of BI and analytics, that have historically required you to bring together a cross-functional, a cross-discipline team of individuals to be able to answer these types of business questions and provide that business data out to people. Today there's the opportunity to do that in a consolidated way with a single individual and a much simpler infrastructure than what was there before. So if you think about the problem that's out there that people face in terms of connecting to applications, accessing and harnessing the data in source applications and turning that data into useful analysis, there's a number of steps that you must go through. It's not just the pretty pictures at the end of the day, it's all of the individual layers that go into it, and they work together as an end-to-end process. Think of it as a manufacturing process for business information. In goes raw data, out comes manufactured information. And that manufacturing requires multiple steps and historically has involved many different tools, many different disciplines, many different people with different skill sets. And that interdisciplinary problem has really kept business analytics out of the hands of a large community out there. It's important to keep in mind that generally speaking, historically, maybe 70% of the cost of an analytics implementation has been people cost, time, energy, and effort of putting these solutions together, in addition to just raw infrastructure and storage costs. So if you don't just reduce the cost of storage, if you leave the cost of the human capital involved in the maintenance and management of it, you still have relatively high barriers to unlocking the benefits to data for a broader part of your organization. And Birst is really focused on attacking that that how do you manage data on top of that data infrastructure to lower that cost as well, so you really can bring down the barriers to analysis in organizations. So if you think about it, you need to connect to applications, not just once, but many times. And in the cloud, you certainly don't want to load the whole thing every time. You need sophisticated ways to pull incremental data out. You need to be able to denormalize that data because it generally doesn't come in a format that you can simply add it up. All those Hadoop things are nice, but if you just strictly add a bunch of stuff up, that only works for certain data sets. Generally, a lot of the interesting data in organizations requires some manipulation to be able to do something useful with it. You probably want to create some sort of dimensional model so that business users can ask multidimensional questions. How does that process change by product, by time, by organization? And how do orders compare to shipments, compare to returns? Those multidimensional questions are sophisticated. Creating a multidimensional model allows business users to ask those questions. And then ultimately creating a model that eliminates for the end user the need to do sophisticated things like write SQL queries and do stuff like that, which is great for a certain audience, but for the broader parts of an organization, that's probably beyond the skill set that they want to be trained in. And then ultimately at the end, be able to distribute best-in-class insight out to people through dashboards and reports and those sorts of things. And really, historically, all of those different layers were different tools, different subsets, and the more sophisticated they got, the more expensive they got, the bigger the legacy vendors got, and the longer the price list got. And all of this got more challenging for people to implement and deploy. And really the mission of Birst in combination with RedShift is to make this as packaged and simple and automated as possible. So Birst brings together a number of different technologies to support making this simple, and I'm going to show a quick example of both the front end and the back end in a second. We don't have a ton of time here, so I'm going to try to make this as quick as possible. But one of the technologies that we support is automated data warehousing. The process of bringing data in its raw form, being able to denormalize, cleanse, map, and then ultimately turn it into a browsable structure that analyzes things like time and the different dimensionality of your business and helps you maintain and manage that information in a more sophisticated way without employing sophisticated data warehouse architects and those sorts of things, which have been a barrier to adoption by a lot of organizations. This is just a visual of an example. Data Mart is a relatively simple one, but it gives you a sense of how you can potentially load data into Birst and model it and then ultimately create a front end that users can interact with. So if you think about these solutions together, and one of the reasons we're very excited is the ability to package both RedShift and Birst into a single box, leveraging the strength of the various Amazon components, S3 and RedShift, as well as the different components of Birst to provide a full-featured enterprise-class solution to organizations. Be able to take raw data, be able to load it into an operational data store to report on the data as is, but also to create dimensional models, and then ultimately even create analytical sandboxes for different departments or end users to be able to create and manage analytical data sets on their own, and then obviously link them to standardized data sets as well in terms of stuff that's maintained by different parts of the organization. And ultimately also be able to do this in a multi-tenant way, because if you're going to invest in one of these data warehouse infrastructures beyond just the storage of data, you're going to invest in the bringing together of the data, the modeling of it, and the presenting that to business users. You're going to want to get as much leverage out of that as possible, and having an infrastructure that allows you to take that same data set, that same infrastructure, and deploy it to multiple organizations simultaneously, that's a big part of the cloud. That multi-tenancy really brings the cost down, it really brings the scalability up, and it brings the accessibility up as well. So there's a lot of capabilities and a lot of power here by taking advantage of some of the cloud nature of both Birst and RedShift. A couple of things I should point out. The cloud is different. I go back a long ways in the enterprise software game. I used to be at Siebel. We went through several different iterations of trying to take stuff and put it in the cloud. And the first version was, let's just run our stuff in the cloud ourselves, the exact same software we otherwise would have run. And that doesn't really work because the software wasn't designed for a cloud environment. It didn't understand that the deployability needed to be built in. All the hooks and things that were designed to be manipulated in an on-premise solution were difficult to get to and manage in a cloud environment. And obviously, there's a whole bunch of other things that you have to deal with the cloud as well. So ultimately, the cloud is a place where you want a solution that's designed from the ground up for a cloud deployment. And that's really what Amazon RedShift is. It was built from the ground up to be able to support that. Amazon's very good at that, and so is Birst. And when you think about the cloud, there are some unique things that people have historically said about why they would be reticent about hosting large amounts of data in the cloud. How do I get my data in? And do I have to move lots of data? Is there performance issues across, moving all that data around? Well, there can be if it's not well architected. But if it is well architected, and you can move incremental data into the cloud, and you can manage it in place in the cloud with the computing resources that are there without moving it around, the cloud is a very economical and very scalable place to move data. And so it takes a solution like Birst that can actually really leverage the best of what RedShift is by doing all that data manipulation in the database itself, as opposed to moving it out and then doing manipulation and moving it back in, to really harness the power of Amazon. It means doing ETL a little differently. It means doing ETL and transformations and manipulating data in the database itself. If you get really big data sets, you're going to want to leverage the parallel nature that is Amazon RedShift, and it also means you don't want to be moving stuff around across big wide area networks and stuff like that. You want to do it in the database itself, and Birst is fundamentally architected to do that. It also means multi-tenancy is important, because if you assemble this rich data source, you're going to want to be able to let many organizations leverage it, and having a multi-tenant system is pretty important for that. First, just a few facts about us. Before RedShift, which is obviously accelerating our business, we support, I would argue, one of the largest BI instances in the world in our cloud, which is right now about 0.5 petabyte of data, millions of dashboards, tens of thousands of data marts and data warehouses, hundreds of thousands of fact and dimension tables, and 4,000 organizations today are using Birst to load, manipulate, manage, and ultimately distribute information across their organizations. We support multiple different types of organizations. We support enterprise organizations that are looking to take departments or applications and bring those applications online to be able to provide a much more agile approach to analytics than has historically been possible. We support mid-market organizations that simply haven't had access to the infrastructure that was, the 7-figure infrastructures of many of our legacy brethren, and obviously cloud providers out there who are looking to provide analytical applications around their solutions as well, and Birst is a leading provider there as well. So basically, anywhere that people need to take and manage enterprise class data and deliver analytics, that's where we focus. We've gotten a lot of analyst and third-party validation over the last year, and we're growing like a weed right now. So with that said, I was hoping to show folks just very briefly some of the things that they can do very quickly with Birst. It's clearly not going to be end-to-end, but it should give a sampling of the types of things that you can do. So let me see if I can share my desktop really quickly here. Understand that should be working. Okay, so I wanted to just quickly show some end-user business analytics to show how we can make multidimensional analytics accessible to business users quickly, to give you a sense of what that user experience is like. And then I'm going to flip around and show you very quickly how I can build something from scratch on top of Amazon RedShift. So what I'm just looking at here is a dashboard, and everything with Birst sits on top of existing data infrastructures such as RedShift, and allows business users to be able to flexibly filter, drill down, visualize in a variety of different ways, visually select, interact, and basically harness the source of rich and dynamic data sources very easily. And when we can make access to rich and complex data sources easy, we can unlock the value to business people in a very dynamic way. I'm just clicking on a couple of things here just to show folks. Click on, some ways that people can interact with various data sets and see how responsive and how interactive the system is. And imagine that on, terabytes of data across large parallel systems like like RedShift and the power of being able to answer some pretty interesting questions by drilling and navigating and those sorts of things. I don't have a lot of time to go into the UI, but I just wanted to give a flavor for what that looks like. What I did want to show is how one can create one of these instances end-to-end very, very quickly. And in Birst, what we do is we encapsulate not just data, but the data warehouse and the front end all in a concept called a space. And very quickly here, I'm going to take and use Birst. I'm going to create a blank space with nothing in it. I'm going to show you how you can access your on-premise data source in a very quick way load compressed, encrypted data up into the cloud, into Amazon, and be able to build a quick data mart very quickly. So I'm going to create a demo space here with no data in it, no infrastructure. And I'm going to use our Birst Connect module here, which is basically an agent that runs inside the four walls. In this case, it's going to run on my laptop locally here, just to load a quick data set. I'm going to add a task just to show how I can connect to data sources on-prem here. And I am going to connect, I can connect to files, I can connect to databases, other Amazon S3 objects. And I'm actually going to add some tables from a database inside of my machine here called Southwind. And I'm going to show an initial load here, but we have tools and techniques for taking a bunch of tables and doing incrementals and all that good stuff to make the cloud really work. And I'm just going to upload that data to the cloud, making it very easy for, sorry here, I have a little bit of a cough, for non-technical users to be able to take, compress, encrypt, load in a bulk way data into the cloud. And what Birst is doing is separating this stuff up and breaking it into pieces, compressing, encrypting, and then loading it up into the sky. And that obviously works for small data sets. It also works for very large data sets. And we've literally loaded hundreds of gigabytes and terabytes of data that way. And what I'm looking at here is just a couple of different data sources that were loaded into Birst. And it's sitting on top of that relational database that we discussed. And I'm just going to enable these data sources and very quickly model them. Each of these data sources was scanned, and I'm just going to connect them together here. I've got an order detail database here, some orders, some products, different components, and I'm just going to wire them together here, some key foreign key relationships very quickly. Something that somebody that has a basic knowledge of the data can do. And I can analyze the data as it stands right here. But what's interesting, if you're going to load data into the cloud, what you want to be able to do is load incremental data and have the system understand how to manage that incremental update to those data sets. So tomorrow when I load new orders, I'll have new customers. I may need to update some customer data. I may need to add new customers. That change capture, change detection, all of that stuff about how do I manage an enterprise data set, that's what a data mart or data warehouse is for. And what I just did there is I clicked the Update Warehouse button and Birst automatically built a dimensional data warehouse here on the right-hand side. In fact, if you think about it, it's something that you would otherwise have had to hire a data warehouse architect to do. And Birst built that automatically and built the structures, and it basically helped automate the construction of that without me having to become a data warehouse expert myself. And if you look at this, what you see are multiple different sources, and each of these different sources is feeding facts and dimensions and a whole bunch of different data warehousing terms that are sophisticated and complex. Birst is taking care of that for me, so I don't have to do that. So there's a whole bunch of data flows and tables and manipulations and all that stuff that Birst helps you manage that otherwise would be sophisticated and expensive. And the tool sets that manage them don't handle them particularly well also in the cloud. All of the manipulation here of creating this data warehouse, by the way, is happening in the database itself. And so what Birst is doing is loading and transforming that into that star schema data warehouse structure that we just discussed. And when it's done here, I'm going to show you how you can then go and create some reports and analytics off that and quickly start using it as an end user in the DB itself.
Yeah, and you're accessing the whole idea here is you've got Amazon RedShift in the background, but you have other data sources as well. In other words, someone already had some kind of solution in the cloud using your technology, and then you're adding the Amazon RedShift as the sort of heavy lifting data warehouse engine behind it, right?
It's the store underneath the covers, and it's the thing that lets you create those queries and analyze the queries. It's where all the data is actually stored and managed. And the manipulation of it to be able to create queries and visualizations and those sorts of things is all happening in the database itself on the raw data. So there's some very powerful things you can do there. Anyway, that was just a quick flavor of it, but I probably went a little bit over, so I'm going to turn it back to you,
okay, no worries.
Eric there.
No worries. So let me go ahead and we will queue up Claudia's slides. Hold on one second. There you are. Wait, I have to take it back. So this is very interesting stuff. So, Claudia, now I'm going to hand the keys over to you. And if you go through your presentation and just start asking questions, let's find out. Let's get to the nitty-gritty.
Do I do my presentation, or do you want my questions first?
Go. You can do your presentation first.
Okay. All righty. Well, let's go ahead and get started with it. I felt that what I needed to do was just talk a little bit about advantages and maybe a few challenges and things like that, just to bring a little sense of what you might be getting into. Certainly, Brad has covered a number of these advantages: the low cost, the usage-based billing, predictable monthly costs, things like that. On-demand capacity, I think, is wonderful. Easy to deploy, grow, and shrink the users, and so forth. The security high availability we've talked about can also be used for developing in-house solutions, and that's one of the questions I'll be asking Brad, is about the in-house capabilities. How do I do this, and what's the success rate, and so forth. It's also very good for vendors like Birst. They only have to support one platform and one version of an application and so forth. The cloud model gives the vendor a predictable cash flow themselves, so that's kind of nice. There are some disadvantages, and again, these are things that I'm going to ask Brad about as well. The one that concerns me is the second bullet point up there. Certainly for Amazon, the cloud model was a lot of upfront cost. There was a lot of much less vendor revenue. Of course, they had to set the whole thing up before they even had a single customer. And the same thing for you as well, Brad. And then, of course, the setup costs are a little bit higher and so forth. But the second bullet point is one that does concern me quite a bit. Very few companies will have all of their BI environment in the cloud. So what do we do about this idea of we're now fracturing the environment, that we've got some in the cloud, some on premises, and so forth? Could involve very complex integration with the existing systems. And another question coming up is going to be about that. How do we ensure that the data is integrated correctly, that the quality is where it should be, and so forth? Customizations and tuning for large projects, certainly something that would be of concern to me. And then, again, the ability to integrate the cloud application with other enterprise data. For example, I'd like to be able to embed it in my operational workflows. Can I do that? How do I do that? How difficult is it, and so forth? So when we think about RedShift, I do have to give them Amazon credit. Boy, oh boy, they certainly have shaken up our world a little bit. This idea of this from gigabyte to petabyte scale, it's not all about big data. Certainly big data gets an awful lot of attention, but there are a lot of companies that don't have the resources to build out a BI environment, and what they have is little data, if you'll pardon the pun. They may have gigabytes of data rather than petabytes, and where do they turn? How do they do this? So I see this as certainly something that is very useful to those that have little data as well. Fast query I/O performance, of course, they've got Parexel under the covers, and that's always a good thing. They have automated most of the common administrative tasks, as Brad mentioned. I found that particularly useful. You don't have to be a DBA to do this. You don't have to hire a DBA to do this. A lot of it has been automated for you. Their pricing, I looked at their pricing structure, and it is very simple. No upfront prices, no upfront costs. Obviously, you're not buying hardware and software and so forth. And what they've done is a good job of making it industry standard with ODBC, JDBC connectors, and Postgres, and so forth and so on. So those are the good news. One of the slides about the good news. Another one, ability to provision huge database volumes. Yes, I talked about little data, but we can also provision huge big data in these environments now. The other thing that I thought was an interesting comment, I read it in some of the reviews, you don't have this long, protracted procurement process, which many of us face when we're bringing in our own hardware and software. And of course, the customer doesn't bear the cost of the maintenance either. I like the idea that it will grow as you do. Maybe you're with little data right now, but eventually you might get to big data. And it's nice to have a system that grows with you. And again, huge cost savings over years versus the ownership by yourselves. As I mentioned, good elasticity and good performance for very complex analytics with the returns coming very quickly. Some of the things to think about, though, the possibility of an outage. It's happened before. It will probably, I hope it won't, but it may happen again. So one of the things that you should be thinking about before moving into this world is your service level agreements. What should they have in them? The cost of the data migration and integration, and that's a question we're going to talk about too, and that's all about the bandwidth. It's one thing to say that it can hold petabytes of data, but how in the name of all that's holy do we get petabytes of data into the cloud in a really fast fashion? These are relatively new processes. Obviously, RedShift is brand new, just since the start of the year. So what are some of the best practices? Have we gotten any established best practices? The one thing that I will commend Amazon for is that they have a very thorough Getting Started guide, which I thought was quite good. And there is always the thought that higher costs can occur over time than on premises. Per user pricing could go up, for example. So we need to be careful about that. Also, you are paying for all of the data, whether you use it or not. So be thoughtful about what data do you put into the cloud and so forth. Last slide, Birst, as Brad mentioned, all the necessary components, the ETL layer, the semantic layer, multiple deployment methods. They can do dashboards, reports, and so forth and so on. No DBAs, as we've talked about. Obviously, they have a very tight integration with RedShift, and the analytic results are returned very quickly so that the business itself gets the benefit quickly and can react with it very quickly. I do think, my bottom line, RedShift and Birst do give traditional data warehousing players a run for their money. They are obviously gunning for the Oracles, the IBMs, the Teradatas, and so forth and so on. And this is an interesting alternative to those types of situations. So let me just ask you very quickly, Brad. My first question really is about the response. You were talking about it a little bit before we got going, and it was actually something that I would like to hear from you. In terms of the response to this offering, what have you seen so far?
It's been unprecedented for us. If you think back to when we first launched our Salesforce connector, we're cloud, so we're sort of associated with cloud. That was obviously a big, being able to harness Salesforce.com data, and then ultimately other cloud applications. Those were big things, but nothing has come close to the immediacy of RedShift. We've had a couple of webinars and a couple of activities to date that have been 2x, 3x anything we've ever done before. So the interest is definitely there because the cloud's always been, I think, if you really look at it, it's been a cheaper, more cost-effective, more manageable way to deploy things. But there's been enough blurriness around it that it's been harder to discern. This just sort of, cuts right through all that. Amazon's just making it very clear and throwing down the gauntlet on cloud versus traditional legacy deployment. So it's been ridiculous uptake. It's very new, but we've been working actually with Parexel, which is the basis for RedShift, for a year and a half. So we have actually a fair bit of experience with the infrastructure itself, even before RedShift, and the demand has been fantastic.
Well, that's good to hear. My next question deals with the fracturing, if you will. You've been a cloud-based BI software product for quite a few years now. Part of the problem, as I mentioned, is that rarely do companies put all of their BI and all of their data up into a cloud. So you're dealing now with some of it being on premises, some of it being farmed out to the cloud or uploaded into the cloud. And it causes me a little bit of heartburn when I think about this, because obviously one of the big pluses of a BI environment was that it gave you consistent, reliable sources of data. Now we're sort of moving into this world where the sources are not all in one place. They are actually sort of shotgunned in several places. It can be in your cloud, it can be in Amazon's, it can be all over the place as well as on premises. What do you see as a best practice? You've been doing this long enough now that I suspect you've got, best practices here. How do you help companies mitigate or even eliminate this fracturing of the environment? What do you suggest?
So I'd answer that in two parts. The first part is I don't think this contributes to fracturing at all. I think the notion that the world wasn't fractured before this, I think, was a little idealized. In fact, if you look at the world of the discovery tools and a lot of the cubes and in-memory tools and all that sort of stuff, all of that was a reaction to, I believe, the notion that data wasn't ever in one spot, and there are spread marts and data marts all over the place in organizations, and that's sort of what's happened. And that is the reality that is today, and there are many applications in every organization. In fact, a large number of our customers, when we come in, that is the reality even on-prem. So I don't know that this changes the game at all. It does allow you, to the extent that you re-platform in the cloud, to actually consolidate some more than you would have done before, to bring some of those data sets together into a new spot. Because provisioning it is easier. And when you bring multi-tenancy into the situation, you can then actually load different data sets from different applications and link them for the first time, as opposed to having to set up whole separate environments for each of these things. And so I think this actually brings an opportunity to bring those together and help reduce some of that fracturing. That said, the world is going to be hybrid for a very long time. If you have data on-prem that is already structured for analysis, you're probably not going to move that to the cloud. If you have new data sources, you probably are. You want to leverage both. And so this is one of the reasons that I believe that having a semantic layer or a business layer is very fundamentally important to a BI solution if it can federate across the cloud and on-prem. And that's something we've been doing at Birst for multiple years, is really letting you blend on-premise data sources with cloud data sources so that users can see both of them together and have access to both of them in a single environment, and even embed that into their existing systems. You should be able to logically bring this stuff together in a consolidated way, and that's really what our metadata layer allows us to do. So we have a lot of customers, and a good chunk of our customers are actually blending new data sets that are going to the cloud with on-premise data sets that are already there.
And when you say blending, are they using the same data model? Is the other thing that comes to mind is what's the role of governance in this environment then? How would you answer that?
Governance plays the usual role, which is, to the extent that there is an organization that's looking at the data sets, regardless of where they sit, they have to have policies and for how you secure that data and how you manage it. Generally, we're talking about different data sets that have common dimensionality. So I have the common products or common customers or common employees or those sorts of things.
The dimensions of the star schema would be the same either on premises or up in the cloud, right?
Even if it's not actually a star schema, logically speaking, if there are business dimensions that are common between the two, you can bring them together and let people browse across them in a more seamless way. Okay,
all right, and then the other question is about bandwidth, of course. It's becoming, well, I think it will become a problem if we start talking about petabytes of data and trying to upload that immediately. Obviously, it's the initial load that we're talking about. But what do you?
Yeah,
again,
So we took the initial stance at Birst that we had to be able to manage the data in the database for this reason. If we forced you as discovery tools, for example, to reload the data every time, which is sort of their preference, at this scale, that would be challenging. So the initial loads for systems, there's lots of things you can do with bandwidth in terms of breaking things up into parallel streams, loading them in parallel. Amazon has phenomenal bandwidth. You actually can get a lot of data up there very, very quickly, but it's not instantaneous. And that's where having incremental loads of data and being able to integrate that incremental data with the base data that you've loaded in there, that's really the way you can scale this to extraordinary volumes. But once you do that, that means you got to manipulate it in place in the cloud. You can't bring it back on-prem, change it, move it back out again. You got to do it right there in place, and that's where having tools and tool sets to do that, I believe, are important, because the penalty of leaving that database is more severe when you're going across an open internet.
Well, have you seen problems with this yet, or is this not yet? We haven't gotten to the volumes where it actually is causing problems.
Well, we've got customers in the many terabyte ranges that's fine. I mean, it may take a little bit of time to load a bunch of data initially, but they're managing it. Even on-prem, it still takes time to move data. And if you think about the connectivity that Amazon has, and the fact that when we load into Amazon, we're loading into S3, which is a giant distributed block store that can then parallel load into the database. There's a lot of tools for moving data very, very quickly at your disposal in an environment like this. The key is just to be intelligent about how you do that. You don't want to load a terabyte every day over and over and over again. You want to only load the new data and new changes, and that's why change detection, change capture, all those things I think are important.
And you have that in your own capabilities, right?
Absolutely. We sit on top of the database and support mechanisms for doing that so that you don't have to load all the data every time.
Just the change data.
Yes.
Okay. And then you touched on this, and I thought it was interesting, so I want to pursue it a little bit more. And that deals with, when does it not make sense for a company to move to the RedShift Birst combination, BI combination, but rather stay on premises? You talked a little bit about that, so let me just probe that a little bit more. What would you say? When would you say to someone, no, look, stay where you are?
Yeah, well, so we have an appliance as well, which allows you to run Birst on-prem. So we do have experience with on-prem, and there are cases when that makes sense for companies. Sometimes there are regulatory reasons that require that. A good chunk of our business is other cloud providers that are embedding analytics in their solution in their data center. So in that sense, on-premise is somebody else's hosted environment. There are situations where where that makes sense. I think in some environments, Amazon does a pretty good job of raising the security bar pretty high, but even in our data center at Birst, I think some of the security standards are even higher. And there are some organizations that have internal reasons for not wanting to have that data leave. And in those environments, you can take advantage of that same style structure, but you want to run that on-prem.
And then along with that, one of the things that we can do on premises relatively easily is we can archive data when we no longer want to use it, or we can put it into cheaper media, whatever it is. You've got this whole idea of hot, warm, and cold data. As data ages, no doubt, it's not accessed as much, and why are we keeping it on our very expensive, mechanisms? Is there any sense of that in the RedShift environment? Do they have some kind of capability of separating data by this kind of, hot, cold, warm, whatever, multi-temperature type of archiving?
I think Amazon's. I can't speak to their product roadmap because obviously it's theirs and proprietary. But those are the kinds of things that they're working on, and Amazon does. If you look at the AWS infrastructure in general, S3, the Elastic Block Store, those types of things. There are multiple different structures with different economics that Amazon has, and they do have ways. Ways of backing up data as well. But the interesting thing is part of the reason you wanted to move stuff in these systems out of your expensive data warehouse is that, in the old days when it cost you $1 million a terabyte or $100,000 a terabyte, you wanted to get data out of there. But at $1,000 a terabyte, you have a lot more options to leave that data in there and queryable. That's one of the big exciting things about big data in general is I can put it all in there, and even if I don't necessarily use it all the time, the economics are such that I have the option to leave it in there so that it could be queryable if indeed I need it. So I think it really works both ways. There are some things that you might want to do that are similar to on-prem, but given the cost equation that's changed, I think there's an opportunity to rethink how you manage your data. Given that it's replicated, it's backed up, the reliability of the Amazon data infrastructure is really, really high. You can do some things with it that you couldn't do with some of those hot, warm, cold infrastructures of old.
Well, and that leads to one of my last questions. I'm running out of time. I'm probably going to get the hook. But that's if I want to bring the data back in premises, on premises, as opposed to, in other words, it's in the cloud and I want to bring it back home, how difficult is that going to be?
Well, assuming you have a relational database that can handle that, you'll obviously have to spend money on that infrastructure. But the nice thing about a database like RedShift and a system like Birst is that the schemas and the data is portable, so you can export it and bring it down. It'll take a little bit of time, but it's not that bad, and you can bring it back down and we'll bulk load it into your existing systems if you really wanted to do it. So you're not confined to the cloud. If you really wanted to do that and bring it back on-prem, you can. We actually have customers that like that option to know that if they ever really want to, they can bring it back on-prem, and that's that's as much a security blanket to a lot of folks as it is a practical thing. But it's nice to know that you can do that, and if you ever get bought or acquired, you want to make sure that that's an asset you have control over. There are definitely things you can do to bring it back on-prem.
Well, and your company also offers people the ability to. Obviously, you have Birst on premises as well. So
yeah, that's actually a feature. You can elect to bring it back on-prem at any time.
Yeah. Okay. Which leads to my last question, then I'll turn it back over to Eric because I can see from the question area, holy cow, we got a lot of questions. One of the things that comes up a lot on multi-tenancy, it is one app, it is one infrastructure, but there are multiple customers, companies there, and everybody likes to think that they're unique, that they're different. And that leads to a bit of a problem because they want to have something that's customized to their needs. You
Absolutely.
and Amazon want to have something that is easy to maintain and that can be of benefit to multiple customers, the multi-tenancy type of deal. How do you support customization while not losing your mind and maintaining this idea, or at least the low-cost idea of the one app, one infrastructure?
Well, so I think that's where we might differ with other folks out there in the sense that, I used to sell analytical applications, and they were a great pitch, 85% reuse from customer to customer, all that goodness. The reality of analytical apps is the reuse is much lower than people think. And everybody does have different apps, and even the apps that they do have, if they are the same, they've configured them differently. There does have to be configuration, and there is a platform component to this. So it's important to understand when we say multi-tenant, we don't mean single schema. What we allow folks to have, and I showed us a little bit ago, is a data modeler that allowed you to model your own data set. Now that may go in a common instance, a common infrastructure with a bunch of other folks, but you can have your data structure the way it suits your data, and I think that's the key thing there. Can you model various people's data structures and support the different data infrastructure that people have? And the answer with Birst and RedShift is yes, you can do that. I think that's very important. If this was a one-size-fits-all pre-built data model, that would be very difficult to apply cookie cutter to the broad marketplace that's out there.
Yeah, that's what it started out with, a lot of SaaS BI, and those companies didn't last long.
No.
I think they're wise to not go down that road.
It's a race to the bottom because, every company, it's the least common denominator interesting analytics. You want to be able to support the uniqueness of each company, not the common stuff.
Exactly. All right. Well, many thanks to you, Brad, and to Birst, and also to the Bloor Group for letting me talk on the briefing room. With that, I'll turn it back over to you, Eric, because I know we've got lots of questions.
Yeah, we sure do. So I'm just going to dive right into these. And you made one comment I thought that was very interesting, Brad, when you talked about data that's already on-prem. You're probably going to keep it, and probably these capabilities of Amazon RedShift are going to be used for new data sets or for augmenting existing environments. I think that probably makes a lot of sense. I mean, I'm guessing what we'll see is people test the waters, try to figure out how useful this service is to them. Obviously, it can be very useful. Data warehousing, we know what all that fun stuff can do. But there is this sort of on-premise versus cloud issue, and we have lots of questions all around data governance and data lineage. What kind of data lineage capabilities do you have, and would they be visible through Birst? Because I'm guessing what you're showing us here, and maybe I could make you the presenter if you want to show another demo, just in case. I put up a diagram from Amazon RedShift's website right there so people can get some view into the architecture that they've got. But I'm guessing that in terms of data lineage and so forth, that's going to show up through Birst, right, as opposed to through
Correct.
RedShift.
Yeah. So if you can model data, so the idea is to provide infrastructure where you can load data either through Birst, in which case we handle the loading process and the modeling of data, or load data directly into RedShift, but then model it with Birst. If you can do that, once there is that modeling layer on top of that, you then have the ability to look at the data lineage for how that data moves through various, certainly if you use RETL and those sorts of capabilities, that'll support the ability to see how data moves from point A to point B to point C. I think in the demo I showed clicking on a source and seeing where the different things it drove, and then ultimately being able to then tie that also to which reports use it and which users actually click on those reports. All that is part of data lineage, and as the cloud matures, that's going to get even more robust. But that's actually a big part of what we consider enterprise class BI capabilities.
That's a good point. And I'm guessing you would recommend that if someone wants to use this service, that just for the purpose of having one source of information about governance and lineage and so forth, that you would recommend loading into RedShift through Birst. Is that right?
We would make it easier, and we would help the modeling on the way in. Yeah, I mean, you can do it both ways, but that we would be able to capture all of that information of where the data is coming from in that process.
Okay, good. Let me dive into some of these questions. So one of the attendees asks, are you promoting that end users, non-data architects, can create their own data models, or do you think they should still have architects in there helping them with that?
The goal is to do two things. The goal is to reduce the skill level required to produce a good data model quickly, so that you don't need the top 5 data architects in the world. You can have people who may have more multifaceted skill sets be able to support this. So that's important to lower what is quote unquote a data architect. If you're building a data model, you want to have some data knowledge, but also in a previous slide I showed sandboxes, and we do also believe that you don't necessarily build a data mart for every user, but the ability for users to create their own sandboxes with maybe a few tables or 5 or 10 tables where they just connect them. That's something that business analysts can do, and if they can link those tables to stuff that maybe other more sophisticated analysts built, that gives you some real power there. And so we do believe that business analysts should be allowed to put some of their data and model it. They may not be able to reach the full richness of a sophisticated data model, but they can interact with other parts of data models that were designed by other people.
And I threw up this slide too, just to give some perspective on how the environment will ultimately look. And I'm guessing what you were also alluding to before is that as we increasingly leverage the cloud and benefit from the price performance and all these types of characteristics, that slowly but surely an organization may start migrating more and more data sets up into something like Amazon RedShift just to deal with the cost structures. And what you want to do is kind of have a long-term plan of how you're going to get there. But to Claudia's point earlier, and I think to some questions in the queue, there are some concerns around how do you get that strategic view of things? How do you reconcile what you have in premise with now have in the cloud. I'm guessing you're going to suggest a sort of thoughtful approach toward onboarding new data sets through Birst into RedShift to augment your environment, right?
There's new data sets, and also a lot of times some of these legacy data sets, as they sit on-premise, they're not terribly browsable or usable today. You're getting some value out of them, but you can significantly soup them up if you move them into a more modern dimensional infrastructure like the one we're talking about here. That said, I do notice in the community out there that the folks, I think data governance is it's something to be careful of and have a vision to how you're going to do that and a strategy for it. But let's make no mistake, business users and people in the organizations are already going around that today, and you have zero visibility into them right now, none. So you're deluding yourself if you think you have control over that today. What this environment allows you to do is have a more flexible, agile approach to bring more of those people back into the fold, so you actually can expand data governance. Because if you put a hard line and put that iron curtain around your data warehouse, I guarantee you 90% of the organization is just going to go do something else. And the whole rise of discovery tools and desktop BI, that's all about getting outside of that iron curtain. And you know, I think having a flexible approach, an agile approach, is really where organizations are going.
Yeah, and I like the point you made about Hadoop and MapReduce as well. The fact that now with Amazon's price point, and let's face it, one thing we've learned about Amazon's price point for web services is that it has a habit of going down. Right? They're dealing with competition from Rackspace and from other vendors out there, and so they are very assiduously lowering their prices as they can, which obviously is a pretty compelling strategy. But this whole concept of MapReduce and Hadoop came around as a way of enabling very low-cost storage, and what you're suggesting is that now with Amazon RedShift's pricing model, you can basically take advantage of this cheap storage without having to get a bunch of Java programmers and do Hadoop, right?
Yeah, definitely. I mean, what MapReduce provided you was unmodeled data structures to begin with, so you didn't have to model it ahead of time, which obviously paid a huge price when you're trying to do ad hoc queries for the unmodeled structures, and low cost. What RedShift provides you is essentially very comparable cost, and modeled storage, which isn't as big a penalty as some folks would make it out to be, and the benefits of that in terms of the ability to join data on the fly of very disparate data sets, I think we've proven over the last 15 or 20 years, it's the value of data is bringing data sets together in a very ad hoc way, and that's what these something like RedShift really makes very powerful. That's where a lot of the value is.
Yeah. What about security concerns? I mean, obviously you've got a multi-tenant environment, but you, I'm sure, separate data sets one to the next. I mean, how do you actually deal with security issues?
So there's how we organize data internally. As I said, there's different places you can put data in the database so that the data sets themselves are discrete and secured, so logically people can't get to them. When people talk about security, they're generally more concerned, at least the overarching thing that you hear about is the data center itself secure? And I think we've reached the point now where we've passed the tipping point where it's safer to put money in the bank than to keep it under your mattress. You're going to get better security in an organization that has the economics of scale of something like Amazon or a cloud provider that does this for a living. And then the question is, can you, as part of that, are the logical mechanisms there to support data level visibility and permissioning and those sorts of things to put security structures on top of that physical data to make sure that the data is properly permissioned? And that's, again, one of those enterprise class things that we focused extensively on, as the on-premise providers have done historically, to make sure that you can permission data appropriately and segregate it. That's a big part of it.
Okay, we got a bunch more questions here, so I'm just going to try to hammer through some of these. Thank you for answering them all so candidly. So one of the attendees asks, is there a free developer environment where practitioners can go and try out the platform and determine how it can be integrated with our clients' BA capabilities or BI capabilities?
That's a great question. We are actually going to be rolling out this quarter a free developer version of Birst, limited number of users, but full-featured Birst on top of RedShift, where you can go and develop and play with and have fun.
Okay, good.
So it's not available today, but it will be. shortly.
Okay, and here's another one. Do you allow the composition of analytic data models that pre-process the raw data into aggregates?
Yes, absolutely. Because even in a data environment like that, sometimes you want to build aggregates to be able to pre-compute some stuff that might be expensive. And also aggregates can store special types of calculations that are difficult to do on the fly, from calculations perspective. So we actually have structures that allow you to not just pre-aggregate data, but pre-transform data as well, denormalize, and cleanse and essentially transform data to create different structures. That's important. And we want to do that when we do it in RedShift. We want to do it in parallel, so we take advantage of the fact that you've got parallel storage and compute to get the speed, because at that scale, if it's not in parallel, you'll have issues.
Okay, good. All right. Here's a really good question. Is there a way to estimate how much space you will need? For example, a ratio of user content to RedShift database size, like 1 to 100 for content, ABCD of X bytes of data, etc. How should someone estimate how much space they're going to need in RedShift? And I'm guessing that that's all very scalable up and down, right?
It is scalable up and down, and the nice thing is that RedShift has some nice tools for, as you need more storage, you can add more nodes, and they will, in the background, repartition the data under the covers to spread it out, so you can continually add more stuff as you need it, which is very nice for what they have. This is one of those, what makes our world of analytics fun, but also makes it difficult to put in a breadbox, is everybody's story is a little different. We do have some processes here at Birst for helping folks get their arms around scale and scope and size, but it is difficult to generalize because we do see such very different application sources and content that are out there.
Sure, I can imagine. And what about, so let's talk about a couple things underneath the covers here. So obviously ParaXL has a relationship with Amazon Redshift. They're using part of that ParaXL engine. And I'm pretty sure that's the extensibility layer. Can you kind of talk about your awareness of what ParaXL's engine does for Redshift?
Well, ParaXL is the database. Amazon's extended it, and they've built on top of it, but the actual database engine itself is ParaXL, and so it runs the same SQL, divides up queries and optimizes them, same sorts of ways. Amazon's built that into a structure for management and backup and all that, reliability that is part of the Amazon system. But the actual database itself is what they work with ParaXL on. And we've also been working with ParaXL and have been, know how to load data warehouses in their database and manipulate them and query them. And I've been doing that for some time now.
Yeah. Okay. Good. Here's a funny question. An attendee writes, the Redshift pricing model is pretty open. How open is the Birst pricing model?
Good question. As you can imagine, we have more dimensionality in our pricing model than Amazon does. Amazon has the luxury of only having to worry about storage. We have a bunch of other things that drive usage at Birst, application content, number of end users, as well as data. So data is one big component. We also have a much higher support model than Amazon, because we are maintaining the application layer. So when people call us up to ask about their data model or ask about certain things, we have people that are there to support them, which is different than the Amazon model, which is if you don't really know, put your knife in your teeth, and if you don't know how to do it, you're kind of on your own on some level. With Birst, we're providing that expertise, that BI competency and analytical competency to go with it. So we do have a higher fixed cost, but our standard server price is somewhere in the neighborhood of $35,000.
Okay, good. Thank you for that. And I'll just throw a couple last questions at you folks, and we will pass on all these questions to the folks at Birst to get back with you later if you feel a question was not answered. Where was it? Oh, what about using things like CA Irwin and other data modeling tools? I'm guessing that Birst plays well with all that.
We do. I mean, you can model data with those tools. The advantage of using our modeler in conjunction with that is that obviously we're implementing the analytical rules for how you manipulate a data mart or data warehouse. Irwin and those types of tools tend to be if you want to do it all manually. and they're fine. But if you want to bring automation to it, one of the earlier questions Claudia had was, how do you handle configuration? And some folks have tried to pre-build applications to be able to make that easier. Our whole approach was to bring automation to it. If we can have the system be more intelligent in the way it builds data models, the physical data models for you, then we can scale you and lower your skill level that's required. So if you use one of those tools, you're back in there with the the experts, and you don't take advantage of all of the automation that we provide.
Right, and so we have a couple more questions. I'll just throw this last one at you. How do you prevent stovepiping? And I think this goes back to what we were saying earlier. Like, you really, I'm guessing, are going to encourage people to manage RedShift and other cloud-based environments through what you traditionally offer through Birst as a way of dealing with stovepipe issues, right?
Yeah, I mean, stovepiping is an issue if you can't connect the sources. If you can put them in an environment and you have a logical way, through a metadata model to link those different data sources, all of a sudden, they're not logically stovepiped. They may be organized or stored in pieces, but that's probably okay, as long as you can connect the data and get and you can manage them in a broader governance fashion. If you have to do it individually and they're managed separately, that's where you have more of those challenges. But if you can connect them and link them, then I think you can manage through a lot of that.
Okay, and one last good curveball here. One of the attendees asks, can Birst connect to JSON web APIs as the data source?
We do have support for a number of different APIs, including web APIs. You have to do some connectivity. We also do have an open connector framework that allows you to basically add connectors to Birst of your own creation to add all sorts of stuff if you want. We've actually opened that up in the last quarter so that people can write their own connectors to different data sources if they like. And we do see a lot of application-specific stuff. There's a few common ones that we see across, and then there's a whole bunch of smaller ones that are out there, and we wanted to make that more flexible for people.
Okay, great. Well, folks, thank you so much for all these great questions. I don't think we got to them all because we burned through 72 minutes and they're still coming in. But we are going to make sure that we hand on all these questions to our presenters here today. Big thank you to Dr. Claudia Imhoff for her time today. Big thank you to Brad Peters of Birst, and to the folks over at Amazon. This RedShift thing is it's real. It's going to be here for a while, folks. There's one great question I see. Can RedShift replace a mature active EDW environment with Teradata as the database and Informatica as ETL and MicroStrategy as reporting, analytics, etc.? I mean, I'll try to take a crack at that one. Depending upon how complex that environment is, as Brad suggested, you may want to leave some things just where they are, but it pays to explore these opportunities. And what I would suggest is to start incrementally tinkering around up in that environment. And if nothing else, use it to put pricing pressure on your current vendors, because pressure can be a useful thing to get a better price and to get what you want. So don't endure pain if you don't need to, and remember there are options these days, folks. And with that, we will bid you farewell. We do archive all these events, so fear not. You can go to insideanalysis.com, look under the Webcast section, and check out all the archives. The archive is usually up right away, so we'll try to get that up very quickly. Thank you so much for your time and attention, folks. This has been a great briefing room. It's a record breaker, almost 700 registrants and about 350 or so live at least. So thank you so much, folks. With that, we're going to bid you farewell. Take care. Bye-bye.